The first two did end up with fractions. Your number line does not have to match mine, and I'll explain a little bit here in a second. So, remember that when you are solving these inequalities, it is very similar to when you're solving equations, except there's an inequality. We're not changing it, but the method is the same. So we would distribute the 3, we would combine our terms, and then we would try to solve for x. So add, divide. Remember that if you divide by negative, your sign changes direction. In this first one, that did not happen. So we don't have to worry about that. I did, however, split how this was written, just so that in my mind it's easier to look at it and read it left to right, and then to read it right to left and have to remember which way the error was. So the way I solved it, I had x on the left, but if I read it backwards, x is still greater than or equal to -this. So if you flip it, just make sure whatever direction that you're pointing to or from the x is in the same direction. If you were to put this in your calculator, this is the decimal 1.8. So, couple different things. Make sure you're using your interval notation. So this would start at 9/5 and keep going to the right, so towards infinity. That would be a closed circle going to the right. And then you have different options for your number line. So I counted by fifths, because this was 9/5. So 10/5 would have been 2, 11/5, and just went like that. That does not mean you needed to do that. If you changed it to a decimal, you could have done 1.8, 1.9, or 2, 2.1, keep going like that. You could also not use decimals at all. Let's say you knew this was 1.8. Let's say you did 1, 2, 3, whatever. Then you would just do a closed circle that's really close to 2, but not quite at 2. So you can do a bunch of different things for this number line. Just make sure you fill it. Any questions? Do you have any questions on number 1? For number 2, similar things. Distribute, combine your terms, start solving for x. When you solve for x, you get -1/2. And because my x ended up on the right, I wanted to switch it so that my x was on the left. So x is greater than -1/2. Strictly greater than, so that would be an open circle going to the right. Again, I did mine by halves. You could have not done that, or use whole numbers, or anything similar. Interval notation, this would be both in parentheses, so -1/2 to infinity. Do we have questions on that one? For number 3, we need to know which of these values are in the solution set. So we I don't know, I did solve this to begin with to see what my final answer would be, which was x is greater than 1/3. So that means as I'm looking at these numbers, I'm looking for which of these numbers are greater than 1/3. So if my 1/3 is here, 1 is definitely greater than, 2.5 is definitely greater than, 1/3 is equal to, but my sign is not equal to, so that would not work. And then -1 is obviously less than, so that one would not be an answer as well. You could have also, once you've gotten this answer, put each one in for x. -1 is greater than 1/3. That's a false statement. That would not work. 1/3 is greater than 1/3. That's also a false statement because they're equal. 1 is greater than 1/3. That is true. 2.5 is greater than 1/3. That is true. You could do it that way as well. Questions on number 3? Number 4. This one was a little weird because as you start solving this, your variables disappear and you end up with 0 is greater than 15. Previously, when we had equations, we would say no solution, infinitely many solutions, whatever. In this case, we have to change how we see this and look at it as, is this a true statement or is this a false statement? So as our variables disappear and we're left with 0 is greater than 15, so that's not true, it's false. So we would just stop by saying this is a false statement. This inequality is false, either of those. We wouldn't do anything else with it. Do we have questions on that one? Really quickly going over the 2 on 5C. So for both of these first 2 questions, it asks you to find some answers. So you needed to set up your equation, find your variable, define it, and solve. So for this first one, you may need to look back at your inequality words to see what is what. So at most is like no more than, can't spend more than what he has. She has. So she can't spend more than $50, so that would be less than or equal to 50. And then we know the rental of the snow cone machine is $25 for the day, so that's $25 no matter what. And we know the flavored syrup, the ice, and the paper cones will be 70 cents per serving. So we don't know the number of servings. Oh, snow cone. Yeah. Yeah. Because that is what it specifically asks for. So we don't know the number of snow cones, which would be like each serving. So we could solve for that. So we're adding the cost for the snow cone machine for the day plus the charge per serving for all of the ingredients or utensils, whatever you want to call that. And then we would solve for x. And then because we can spend no more than, we have to decide, one, this has to be a whole number. Would it be 36 or 35? If you put 36 in, you would go over the amount of money she has. So we would have to do 35. Questions on number 1? For number 2, same thing, except now this is no less than. So it might cost $159. It might cost a little bit extra with like tax and things like that. So this would be similar to at least, which is greater than or equal to. So greater than or equal to 159. The 38 into savings account is what is there already, so we wouldn't put a variable with that. And then we don't know the number of bags of leaves he would need to rake to clean up to get this amount. So your variable would represent number of bags, and then you would solve. After you solve, you get a decimal again. Number of bags should be a whole number, so we have to decide how many bags, 24 or 25. In this case, because it needs to be at least 159, if we round down to 24, and if we put 24 back in, it doesn't get him his base amount, his 159. I think it's 158 actually. So the minimum amount he would need is 25. If you put 25 in, it would go over the 159. That's okay, because we need to cover like extra taxes and things like that. But 24 would not be enough. The 25 is our answer to that one. Do we have any questions on that one? Okay. Before we get into our notes for the day, I did want to remind, I feel like I said this Friday, but just so you have another reminder, and I'll say it again at the end of class. On Thursday, so next class, you guys will be taking your SOL pre-test. So you'll need your laptops, and that's really all we're going to do that day. It may not take you the entire class. It may take you the entire class. There will definitely be questions you don't know because there are things that we have not covered yet. The entire thing is do your best. Try what you for sure know. Try what you think you know. Anything else you have no idea, it's okay to guess if it's multiple choice. Guess in a random answer if it's fill in the blank or anything like that. Eric?
Is it graded?
I mean, like it is because it's going to go formative, but like I'm not going to put it in right now. It's purely to see where you're at. For me, the STAR assessment did that, but that wasn't really for me. Right. Other questions about that? Okay. You all should have notes that look like this. So last class we talked about just solving multi-step inequalities and word problems. Today we're going to take that a step further. I don't remember what the first was. The compound inequalities are two inequalities or more. We're only going to deal with two. Join together with an and or an or. While we're doing these notes, everyone that has a computer open, make sure those are closed so I know you're paying full attention. Okay, so there will be two different types of compound inequalities and you'll need to know which ones are which. Is anyone done with this part? Reese, go ahead and close your laptop. Go ahead and close your laptop. Or inequalities have a tendency to graph apart. We'll see what that means here in a second. So when we have or inequalities, let's say we got some answer, it was x is less than or equal to -2 or x is greater than 3. We would graph both of those parts. So x is less than or equal to -2 would be a closed circle going to the left. And x is greater than 3 would be an open circle at 3 going to the right. So when you have or inequalities, they look like they're going away from each other. Now this is a little different on the Khan Academy, so later I'll explain what exactly that is doing. So when we look at this interval notation, we're still reading left to right all the way across. Where would we start with this?
The lower number.
Lower number.
So if the x is less than.
What is the very lowest number on this? If this keeps going to the left. Negative infinity. And then from negative infinity to, where does it stop? So there, if it was negative infinity to positive infinity, this would snap. It would keep going all the way through. That's not the case. It stops and then starts again. So where does it stop? There'll be multiple parts. So where does this one stop?
Negative 2.
Negative 2 first. This one's included, so this would have that square bracket. Then because this is an or, we're going to write or. Then it starts up again, so we're going to put it at 3, but this is open, so parentheses. And then where does this stop? Infinity. So when we have or inequalities, they're going to graph away from each other, or graph apart, but also their interval notation would be like 2 parts. From negative infinity to some point, and then or another point to infinity. And we'll do some more problems just in case that didn't make sense. Okay. Questions so far? So let's start this. When we solve or inequalities, we have 2 different inequalities that we have to solve. So what I do over here, I'm not doing over here unless they happen to have the same numbers. You're solving this completely separate. So here, to solve this, I would get rid of the 4 by I. And that would give me x is less than negative 3. Notice I did not do anything to the other side because these are different inequalities. Always bring down the or, and then solve the other side. So in this case, we would be dividing both sides by 2 to get x by itself. So this one would be x is greater than or equal to 6. So we now have our or inequality, and we can graph it and find our interval notation. X is less than negative 3 would be an open circle at negative 3, going to the left. X is greater than or equal to 6 would be a closed circle at 6, going to the right. How would we write this interval notation? Parentheses?
Parentheses. Negative. Negative 2.
This one would not be.
And then or. Close.
Always be looking at whether your numbers are open or closed, because that will tell you if it's parenthesis or bracket. And it could change for each problem. Javier.
So why is there a bracket on both sides for the load?
For infinity or negative infinity, it's always a parenthesis, no matter what. What other questions do we have on that so far? So it looks complex, but really it's the same thing we were just doing with simpler equations. There's just not two of them. What is it? 6 problems on here? 5. Let's do. Let's say we do number 4. Same thing. Solve one side, then solve the other. Doesn't matter which side you do first. So if I'm solving this side, I would do what to get x by itself? Add 14 on both sides. On both sides of this one, not to both inequalities. And then from there, divide both sides by side. And then the other side, we need to do what?
Take away 5.
Subtract 5 from both sides. And divide by 4. Is my sign going to change here? No. Now, as we're looking at this, it may look a little weird because this one is greater than and this one is less than. So don't always assume whatever's on the left is going to be the one that faces to the left, because that may not be the case. If you want to rearrange it, you can, but you don't have to. So if I'm going to start graphing this, x is greater than or equal to 2, that's still going to be a closed going to the right. X is less than or equal to -2 would be a close at -2 going to the right. If you want to rearrange it, you definitely can. To make it look more like what you drew on your graph, but you don't have to. Interval notation, we are starting at -infinity, going to -2. Parentheses or a bracket, or, and then another bracket. Have any questions so far? We're going to do one more of these type and then we'll move on to and. So we'll do number 5. With number 5, we have something we need to distribute, or if we wanted to, we could divide both of these sides by -3 because they're both divisible by 3. You would just need to remember because we're dividing both sides by a negative, the sign would change. So we're going to do that one both ways so you see what would happen in that case. So first I'm going to go ahead and distribute the -6x minus 30 is less than -15. Add 3 to both sides. Divide both sides by -6. Would my sign change here? Yes. Before I do this the second way, I'm going to go ahead and do the other equation. So in this case, we would need to subtract 1 on both sides and divide by a negative, which would again change the sign. before I graph these and do the interval notation, I'm going to go ahead and do the second way of this. I'm going to go back and rewrite this. You do not need to write this down, but if you want to, so if I were to start off this one by dividing both sides by -3, this is how this would work. Now I have 2x plus 1 is greater than or equal to positive 5 because I divided by a negative. And I would keep solving, subtract 1 on both sides, and divide both sides by 4. I would still get the same answer, except this was not equal to. So I would still get the same answer, just solved it a different way. Right, so for the first one, we have x is greater than 2, so that would be open circle to the right. And then the second one, x is less than or equal to -4, close circle to the left. So our interval notation would be -∞ to -4 with a bracket, or 2 both those circles. Before we move on to and inequalities, give me a thumbs up if you feel good about this. Sideways if you kind of understand, maybe more practice, and you'll be good. Thumbs down if you do not get this at all. Okay. Now, everything we just talked about for or inequalities is the opposite for and inequalities. So and inequalities have a tendency to graph together. You guys don't have that big? Okay. Yep. So it was supposed to be 2 pages, so this is what I'm gonna go do. Pause. What that means is instead of graphing like this, they're gonna graph like this. So for this, if we had x is greater than -6, that would be closed circle at 6, going to the right, -6, not 6, but 6. And then x is less than or equal to 1 would be here. So what's going to happen is when we have and inequalities, we're looking for where do they overlap. So that would just be from here to here. So what we would draw instead of these 2 lines is a closed circle at -6, a closed circle at 1, and a line that connects them. So you can graph it with the 2 arrows and then graph the one where they overlap to help you, but you should still have the one where they overlap, just this one, somewhere on there, if you're doing it that way. So when we look at just this interval notation, if we're just looking at the one in blue, where would that one start? -6.
Brackets because it's closed.
Yep. Where does it end?
1.
1. So this is like the missing piece in between the or that wasn't there. So and inequalities should be shorter, shouldn't have negative and positive infinity. I'll say for these. Khan Academy is a little different. Also, with that, because of this, because they go together, instead of writing them as two separate things, we write them all as one thing. Think back to like your set builder notation. If it was between this and this, it was like 5 is less than or equal to x, which is less than or equal to 6. Same thing. So we would write this, negative 6 is less than or equal to x, which is less than or equal to 1. Remember that your set builder notation, your interval notation, those are the same thing, written in different ways. Oh, that was basically what this one was going to be. So, if I were to rewrite this, that is complex. So when we're solving this, you're not going to get two different inequalities. They're going to be all combined here. So when we solve this, instead of solving them separately, what you do to one part, you're doing to everything. So for 6, if I were to start solving that for x, I need to get everything away from x, just like normal. So I need to subtract 4, but when I do that, I'm doing it here and to both sides. So everything gets done together. So this would give me negative 2 is less than or equal to x, which is less than 5. Notice how it's already in that condensed format, so we don't need to do anything to that. And then we would graph it just like that. I mean, if you have a question. So, yes, you can still do the arrows. I'm going to start with this one and then go back and do the arrows. So if I were to just graph this, this would be closed circle at negative 2, open circle at 5. And then from negative 2 to 5, with a parenthesis on 5, would be my interval notation. So if you did want to go back and start off with the arrows, you would have to read it separately. X is greater than or equal to negative 2. I kind of have to read that part backwards. And then read the second part as is. X is less than 5. And you would still see where they overlap. If you wanted to do that part is not necessary. What questions do we have on this so far? We'll do 9 and then 10, and then I'll let you guys practice the others. For number 9, what would we do first to get the numbers away from x? Subtract 1 to everything. We have negative 2 is less than 2/3 x, less than or equal to 4. Then from there, instead of dividing by 2/3, we could multiply each number by the reciprocal, so 3 over 2. Now, if you have something in the middle that is negative, your signs would still change when you divide. I'll show that here in a second. So this would be -6 over 2, which is -3. This would just be x. This would be 12 over 2, which is -6. So open circle at -3, closed circle at 6. The line connecting them. -3 would have a parenthesis and 6 would have a bracket. So I'm going to do this off to the side on a, let's say this happened instead. Let's say this was -2/3 instead of positive. Then when I take it and I flip it and I'm multiplying by -3 over 2. All of my signs would still change direction. I would still end up with the numbers I have. I have +3 is now greater than x, which is greater than or equal to -6. But you still want this in the format less than. So what you would do is rewrite it so it's lowest to highest. So basically I took this whole thing and I flipped it. So if you did get a negative, that's what you would do. Your graphing would be the same if you flipped it or not. And you don't have to flip it. But if you wanted to, that's what it would do. That's what you would do. Okay. I know you guys are tired of me
So
talking.
you flip the sign, then negative, positive flip.
Yeah, so change the sign because you divided by negative, but then you are completely changing the order between lowest to highest. But you also still needed to say what it said before. So right here, this says x is greater than or equal to -6. If I read this backwards, x is greater than or equal to -6.
They have to point to the
Right, right. Okay. Last one. 10 can be done 2 different ways. So I'm going to do that really fast. One would be to distribute and solve that way. The other would be I could divide each of these by 2 because they're all divisible by 2. We'll do the dividing part first. So this will be -1 is less than x minus 6, which is less than or equal to 2. Then I could add 6 to both sides. All sides. Before I graph that, I'm going to go ahead and solve it the other way. Again, you don't need to write both. So if I distributed first, I'd have -2 is less than 2x minus 12 is less than or equal to 4. Add 12 to both all sides. We have 10 is less than 2x is less than or equal to 16. Divide all sides by 2. So you could do it either way. Graphing this, we have one open circle, one closed circle. Open at 5, closed at 8. Sometimes the lengths in between these are really small. Sometimes it's just a unit apart. Sometimes it could be more than that. Nope, not parentheses bracket. Do you have any questions on and inequalities? I'm going to give you about 10-ish minutes to work through the, I want to say 4 problems, the 2 or and the 2 and that we did not do. Then we'll come back and we'll talk about those. I think that was 2 and 3 for this one. So for 2, we have x is less than 1 or x is greater than or equal to 3. So open circle and then a closed circle. Or negative infinity to 1 or bracket 3 to infinity. Number 3, x is less than 0 or x is greater than 4. So everything should have parentheses here. Both should have open circles. Questions on either of those two? And then for the and, we did 6, we did not do 7. So for 7, the inequality itself was -2 is less than x, which is less than 3. So both open circles, both parentheses, from -2 to 3. And then for 8, -4 is less than or equal to x, which is less than or equal to 2. Both closed circles, so both square brackets going to x. So I forgot that delta math is also like this, so this helps for both. Disregard that the due date is for today. I thought I changed it on both Canvas and delta math. I did not, but you can still do it even though it says late. Give me a second. Let me pull one up. Alright. So this is an example from Khan Academy. What's different about what we did in class and what you're going to do on Khan Academy Delta Math is the ands are still the same. You're still looking for where do they overlap. They don't give you number lines, so I would definitely draw your own number line like on a piece of paper so that you see where they overlap and you're not just mentally thinking about it. The ors is really what's different. So I'm going to quickly go through and I'm going to solve this. And then refrain from packing up until we've gone over this, and then I'll let you guys pack up. So on this side we have, I don't know if I can make this bigger. Oh, sorry. 11x is less than 11. I'm kind of doing this at the same time. Or 12x is greater than -18. And then I can divide on both. Right, x is less than 1, or x is greater than, I'm assuming -3. And if I were to graph those both on a number line, that was not the straightest number line. That's okay. So -3/2 is 0, -1, -3/2 is just somewhere here. And that would be going to the right. And then we have 1, and that would be going to the left. On the notes, I said that or usually graphs apart. Yes, that's still true. With these, they're looking for really everything. They're looking at it as a whole. So they're looking at left to right, what would your domain be? So left to right, I know it starts at -infinity. It does stop here, but it continues with this one, so I can't really say it's not included there. And then again, it does stop here, but it does continue on this one, so I can't say it's not included there. And then it keeps going to the right. So with your ors, you're looking at left to right, what would my domain be? And in this case, it's everything. It's all real numbers. And also, I'm on, anyway. But the answer would be all real numbers. So I would say definitely draw a number line, because it'll definitely help you. The ands, you're still looking at where do they overlap. The ors, you're looking at everything all together. What is my domain of this entire thing? If you want to go through this Work Academy with me, because you still aren't understanding, that's fine. Just come see me before after school and we can go through those together.